Alright guys, so we're trying to find the velocity at time t. So before we know that in order to find velocity, we can just find the derivative of the specific function, or the displacement. So let's do that. We know that the velocity at time t is going to be the derivative of the displacement. So we take this specific function, we take the derivative in terms of t. So this is going to be, Just gonna rewrite it again. Derivative of t cubed is 3t squared. Derivative of this is negative 12t. Derivative of this is plus 9. Okay? And note, because we're talking about derivatives in natural science, we can say that the dx actually represents the unit meter, and dt represents the unit seconds, like so. So this is the application of what we have been practicing so far. Okay, now going back to algebra 1, we can actually factor this, and there's going to be a reason why we do this. This is going to be t minus 1, t minus 3. Okay, hopefully you guys remember that from algebra 1. All right, so that's A at time t. We don't know what the t is yet, so let's look at B. What is the velocity at t equals 2, at t equals 4? So we already have the function here, so I'm just gonna copy this. We know that the function for velocity is this, so we just have to substitute. In this case, we know that t is 2, which is, you can use this function or you can use the other function, doesn't really matter. I'm gonna replace this with 2. It's gonna give you a negative. Ooh, why is the number negative? Can you have a negative answer? Yes. And the negative here represents that whatever the particle is, it's moving backwards. So this is why we use calculus, right? We can determine the velocity, and we can determine also the direction of where the particle is going. And then if we want to find v of 4, we can do that as well. We're just gonna substitute this with 4, and you're gonna get the same, which is 9. Now this is a positive, right? I'm just gonna keep the positive here so you guys can see what's happening with the direction. So in this case, this is moving backwards, and if this is positive, right, this means particle is moving forward. Okay, so moving forward. Now what about the particle at rest? Okay, at rest means v equals 0. So let's do that. We want to find the time where the velocity is 0. So 0, remember the function that we have is t minus 1, t minus 3. So we want this v of t to be equals to 0. Alright, and then how do we solve this? Remember algebra 1? We can use the zero product property, so then we know t minus 1 equals 0, and t minus 3 equals 0, which gives you here t equals 1, and the other one, 3 equals 3. So at 1 second and 3 seconds, the particle is resting. Don't forget, the unit is second. So it's or. So there's two answers. When is the particle moving forward? So remember, moving forward means that you want the velocity to be positive. Now, how do we solve for that? Well, moving forward, whenever the velocity is positive means greater than 0, right? And we know that the function, after we factor it, is that, right? Okay, so this is something new. You might probably remember this from our algebra 2, or maybe not. That's okay. So we're gonna create a number line here. And remember, after we solve, we know that if we make this equal 0, this is gonna be a 1. And if we make this equals 0, this t is gonna be 3. Okay, so really we want to figure out, let's say, any number before 1. Would that make the velocity positive, right? So let's just figure out any number that is less than 1. Let's say you can try any number, right? Any number that's less than 1. 1/2. If you substitute this to this function right here, what you're gonna get is a negative number. If you would substitute 1/2 here, so 1/2 minus 1 is negative 1. 1/2 minus 1 is negative 1. And 1/2 minus 3 is negative. So negative times negative, that's going to give you positive, right? So whenever the numbers is less than 1, you know the particle is going to be moving forward. Okay, actually, sorry, we're gonna start from 0, between 0 and 1. Okay, and this is time, because time cannot be negative, right? So time can be 0, but time cannot be negative. So between 1 and 3, let's figure out a number. Any number you can test. Let's try 2. So if we substitute 2 to here, 2 minus 1 is positive, 2 minus 3 is negative. Positive times negative, that gives you negative, right? And then if you try out t equals, you can say whatever number is greater than 3. 10, if you substitute 10 to this function, so 10 minus 1 is positive, 10 minus 3 is positive, positive times positive, that's gonna give you positive. Okay, so at this interval, the velocity will be positive, which means the particle will move forward. Okay, now before I give you the answer, I want you to know that this number right here, 1 and 3, t equals 1 and t equals 3, is called critical points. Or critical points are when the function is equals 0. Okay, so or zeros. Now let's just write the answer. We already know it. The particle is moving forward when where? When the velocity is positive, which is from 0, between 0 and 1, and when t is greater than 3. Alright? Okay, let's go on to the spicy one. Find a total distance traveled by the particle during the first 5 seconds. Alright, so I'm going to create a number line here. So this is the x of t. Right? This graph right here, we're going to create a graph that shows where the particle is. Okay. So we can just start from 0. Okay. When 0, what is the displacement? So go back to the equation, which is t cubed minus 60 square, t cubed minus 60 square. What's the function again? Let me go back. Plus 90. Okay, plus 90. Oops, that's the function. Let me just put it up here. So x0, that's gonna give you what? 0. The displacement when time is 0 is 0. So let's just write time 0. Displacement is 0, right? At time 1, what'd you get? Substitute it here. 1 minus 6. 1 minus 6, negative 5, plus 9, that's 4. Right? So let's just put 4 here. So the particle gonna move forward. 4. Right? But then if you look at t equals 2, oops, right here, there will be a point where it stops moving, okay? So there will be a point where, so this is after t1, it stops moving because it's gonna go backwards, right? When it go backwards, you see, let's see. Let's figure out x when time is 3. 27, substitute here. 27 minus 18, 9. 27 minus 54, so that's 0. Okay, so it's gonna go back to 0 at time equals 3. Okay, and then again, there will be a time where it stops moving, changing directions. We can try 5 seconds here. 125 minus 6, it's 20 meter. So at 5 seconds, let me just make this so it's proportional. 8, 16, 20, 24. At t equals 5, it goes to 20 meter, right? So that's at t equals 5. So how do we figure out the total distance? Well, the total distance is what? Moving forward from 0 to 1, right? Plus moving backwards from 1 to 3, and the distance moving forward. And why do I use absolute value? Because the distance will always be positive, right? No matter you go back and forth, a distance from home to school is the same with school to home, right? In here we know that this is 4, right? Let me just write in here, moving forward, and this is also moving forward. So this is where the particle moves forward, and that's 4, and the other one was what? 4, right? And moving backward is also, I'm sorry, this one 20. This is 4. So 4 plus 4 plus 20, that gives you 20. Don't forget the unit meter.